Here's what I think we ought to do. I think that we ought to eliminate the taxes on employment, the payroll taxes that discourage jobs, and make it up dollar for dollar. No tax increase, tax revenue neutral, but eliminate the payroll tax, make it up dollar for dollar with pollution taxes, principally
Well, we've got to put a price on carbon. Carbon dioxide is odorless, tasteless, and invisible. We have to make it visible, and we have to put a price on it. Now, there are two ways to put a price on it. I mentioned one, which is to eliminate the payroll tax and replace it with a CO2 tax. I strongly believe in that.
We ought to do. I think that we ought to eliminate the taxes on employment, the payroll taxes that discourage jobs, and make it up dollar for dollar. No tax increase, tax revenue neutral, but eliminate the payroll tax, make it up dollar for dollar with pollution taxes, principally CO2 taxes, and yes, that would raise the prices. And yes, that would raise the price of gasoline.
Okay, I muted out this malignant little corporate whore so I could say something. So he wants to tax us on carbon in the place of our income tax, and then that will in turn make the price of gasoline go up. So if the price of gas goes up, the price of everything goes up, because we are wholeheartedly dependent on shipping for everything. Think about the impact of that. The Earth's atmosphere is composed of 77% nitrogen, 21% oxygen, the rest trace gases like CO2, which makes up 3,000 parts per million. Let's compare the Earth with Mars. Let's talk about the Martian atmosphere. Mars's atmosphere is about 95% carbon dioxide, 2.7% nitrogen, and the rest trace gases. Well, if carbon dioxide is indeed the cause for planets to get warmer, then where the fuck did all this ice come from? That's why Al Gore can be my shiny new bitch. That's right, motherfucker. No new taxes. No new taxes. If anybody out there ever meets this vile little emissary of the corporate cock in person, ask him how in the hell there's this much ice on Mars with a 95% CO2 atmosphere. And if he says Martian SUVs, kick him right in the Viagra pocket.
Sometimes get angry and blast our planet with billions of tons of hot ionized plasma. It's called a coronal mass ejection, or CME.
In 1998, an enormous CME impacted the Earth and caused a satellite to go down over the middle of the United States that happened to be carrying pager signals for almost everyone in the United States. As a result, doctors and nurses didn't get pages about their patients. Anybody who was expecting a page didn't get it, and that had a real impact on our society.
Similarly, the airlines flying over the poles, they can lose communications, and that's not legal for them to be flying in a situation where they're not in communication with the ground.
But probably something that's more important to passengers, and as human beings, you worry about radiation exposure and so on, and especially pilots who have to fly these aircraft over the pole.
One flight over the pole could be the equivalent of, say, 100 chest x-rays.
Large electrical utility systems can get hit with huge power surges.
Especially long grids at high latitudes that go north-south can actually pick up a lot of extra current in them, and power companies are very aware of this.
Long steel pipelines are at risk. To understand why, think about this. This is a power supply and inverting transformer. This one happens to be from my computer. You probably have hundreds of devices like this in your life, either seen or unseen inside of other electrical gear. High voltage, like the sun, comes in this side, and through the magic of magnetic fields is induced to flow across to the other side where a low voltage current, like the Earth, is produced. The problem is, no human engineer wrote the specifications. No underwriter's laboratories verified the safety of the giant inductor that surrounds the entire planet Earth.
When one of these CMEs impacts the Earth's magnetic field, it causes the leading edge of our magnetic field to recoil toward the planet. That in turn changes the magnetic field near the surface of the planet and induces electric currents in anything that can conduct electricity. If it happens over a large power grid, the power grid carries a large DC current.
There was an example in March of 1989 where Hydro-Quebec lost power. Millions of people lost power for almost 10 hours, I believe, and it was attributed to a major geomagnetic storm.
These can be very serious problems for modern technology, especially in the northern latitudes.
And the sun is capable of a whole lot worse than anyone now alive has ever seen. On September 1st of 1859, conditions on the sun and in the magnetic field of Earth came together to create a nearly perfect solar storm.
When the solar flare went off, the intensity of the sunlight doubled. So anybody walking on the street would have noticed this.
17 hours later, aurorae were seen as far south as Hawaii, Havana, and Hong Kong.
The aurora borealis created very intense currents that flowed in the ionosphere, and these currents induced currents on the surface of the Earth.
Telegraph stations across Europe and America caught fire. Several buildings burned to the ground.
People received shocks associated with touching conductors at that time.
And the impacts of that event a century and a half ago may only be a fraction of what the sun can really do.
Our technology is much more advanced now than in 1859, but at the same time, our technology is more vulnerable to a storm of this magnitude.
The sun is our nearest star. It provides us with warmth and light. We all know that the sun is important to life on Earth, but few of us have been given a good description of the sun and its composition.
Our sun is an average star, similar to millions of others in the universe, but it's a big energy machine. If you could capture the energy the sun produces in 1 second, that would supply the United States with enough energy for the next 13 billion years.
Where does the sun's power come from?
Good question. The basic energy source for the sun comes from nuclear fusion, and this is when mass particles combine and tons of energy are released. The core, or innermost part of the sun, is made of hydrogen. The sun is so dense, and its size is so large, that light released from the core takes about 100,000 years to make its way to the surface. If the sun were to stop producing energy today, it would take 100,000 years for significant effects to be felt at the Earth. Scientists think there is enough hydrogen on the sun to continue producing energy for another 7 billion years.
The sun provides the Earth with unfathomable amounts of energy. In 1 hour, the Earth receives more energy from the sun than the entire human race uses in a year. The sun provides the Earth with unfathomable amounts of energy. In 1 hour, the Earth receives more energy from the sun than the entire human race uses in a year.